Hello everyone. Today we are going to discuss about adjoint of a matrix and inverse of a matrix. So, adjoint of a square matrix defined as the transpose of the matrix where Aij is the cofactor of the element Aij. It is denoted by adjoint. Here Aij, small aij is representing the element and capital Aij is representing the cofactor. Okay, so let us go through the example, then it will be clear for us. So let A is a matrix of order 3 by 3, where this is the first row, second row, and third row. Okay. So if we have to find out the cofactor of this one, right, small a1, then it will be represented by capital A11. We have already discussed about how to find out cofactor and minor. Okay. If you go through that video, then it will be clear for you how to find out cofactor of each of the elements. So ultimately, the definition is adjoint A is equals to transpose of the cofactor matrix, right? This is the cofactor matrix. This capital A1 is the cofactor of small a1, right? Capital A2 is the cofactor of small a2. Similarly, like this, okay? Each of the element is the cofactor matrix. Now, if we transpose this one, right? Transpose means interchanging rows into column. Now this row comes to this first column and this row comes to the second and similarly third. So let us take an example where the matrix is 1, 2, minus 3, 5, 7, minus 1, 3, 4, 9. So we have to find out all the cofactor of each of the element, right? It's the position of small a1, so we will find out by capital A11. Now, capital A1 will be the 67. How to find out? Remember, we have to eliminate this row and this column. We have element A11. That's why this column is eliminated and this row is eliminated. 1 plus 1 is 2, even number. So it is a positive sign. Okay. So then you multiply 7 nines are 63, then minus of 4 into minus 1, ultimately plus 4, that's why 67. Similarly, we can find out the rest. So these are the values. Okay.
Now we know adjoint A is the transpose of the cofactor matrix. So if we interchange this row into column, ultimately it will look like this, right? And already we have the value of this cofactors. So let us substitute the value here. So once substitute these values, ultimately it will look like this. Now, so adjoint A will be the value for the given example. Now let us understand the definition here. A square matrix A is said to be singular matrix if determinant of A is equals to 0. And it is non-singular if determinant of A not equals to 0. Here mainly we will concern about this determinant of A not equals to 0. Now theorem, if A is a square matrix of order n, then we have A into adjoint A is equals to adjoint A into A is equal to determinant of A into I. I is the identity matrix here. If we calculate this, if we substitute the values of adjoint A, we know the adjoint A value is this one. So if we multiply with A matrix, ultimately we will have this value. Okay. Now let us understand what is the inverse matrix. For getting an inverse matrix, a matrix should be a non-singular matrix. Okay. So we know from the last theorem, A into adjoint A is equal to adjoint A into A is equal to determinant of A into identity matrix, right? Now, as I already told you, if A is a non-singular matrix, then determinant of A not equals to 0, right? So if it is not equals to 0, we can divide whole by determinant of A. So let us divide this one. A into adjoint by determinant A. Okay. Now let us substitute this one is equals to B. Now A into B is equals to B into A is equal to I. You remember in the number system we have multiplicative identity. A into B is equals to B into A is equals to 1, right? 1 is the identity, multiplicative identity here, and this is the existence of inverse, right? So ultimately what we have, B is equals to A inverse, or we can write A is equals to B inverse. Similarly in matrix also, this is the property for existence of inverse. Okay, so from here what we learn, A inverse is equals to B. And what is B here? B is this value, adjoint A by determinant of A. So ultimately how to find out the inverse of a matrix? So A inverse is equals to 1 by determinant of A into adjoint A. Now let us find the value of adjoint A from the given example. So we know determinant of A is equals to this formula for finding out the determinant value. So substituting, we will have minus 26. So to substitute the value of A11, A capital O11, right? So if we substitute all the values, ultimately we'll have minus 26. Now we will substitute here minus 26, and we have the adjoint A value from the last slide, right? So we will put this value. So ultimately this is our inverse matrix. Okay, thank you.